Hey Geometry! Alright, so today I'm going to be talking about parallel lines and triangles. These are the notes that you guys picked up from yesterday. Jumping right in, there's actually a few things that we need to talk about. And the first goes with this postulate. So if you would, go ahead and get out your theorem and postulate notebook. We actually have two, this one and another one. So if you would, go ahead and copy this down. Sub, if you want to pause this, because it's going to take a while for them to copy it down in their notes, that'd be fantastic. So thank you for pausing it. I appreciate it. Alright, well I assume that was enough time, so we'll move on to the next one. Before we move on, basically it just says that if you have a line, which is line L, and point P, there's only one line through P that's parallel to L, and we use that for some stuff later on. The next part that we have is theorem 3-11. This is the sum of a triangle's theorem, and this says the sum measure of the angles of a triangle is 180 degrees. And then it shows the measure of angle A plus the measure of angle B plus the measure of angle C equals 180. We've talked about this a little bit in class. Now I'm actually giving it to you as a theorem. Go ahead and copy this down in your postulate and theorem notebook too, please. Make sure you're drawing pictures as well. Thank you. So Sub, if you would pause this, that would be fantastic. Alright, moving on. The next part that we have in your notes is the auxiliary line. Auxiliary line is what you add to a diagram to help explain relationships and proofs. So the red line in this proof is an auxiliary line, which we then use for this proof here. So what we have is a few statements. I'm going to do my best to draw in here. It's a little bit weird because I'm drawing with my finger on my actual laptop screen because it's a touch screen. So I'll do my best. So it says that we draw line PR through B parallel to AC. So this says I'm going through a point, and then I'm going through another line, and I say that PR is parallel to AC, and that was the parallel postulate we just talked about. PBC and angle 3 are supplementary. So PBC is basically angles 1 and 2, and it says angles that form a linear pair are supplementary, and it says definition of supplementary angles. So essentially what the definition of supplementary angles is that it's really implying what the previous thing said. So that's angle, so the measure of angle PBC plus the measure of angle 3 equals 180. So the next part says that the measure of angle PBC equals the measure of angle 1 plus the measure of angle 2. That's the angle addition postulate. That's something that I haven't given to you, however, you have it now. It's two angles sum up together to be the bigger angle. You can also do angle subtraction postulate and so on. Then we have the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180. And if you look very carefully, you can see that the measure of angle 1 plus the measure of angle 2 was the measure of angle PBC, which was this up here. So what we're doing is we're taking what we know is something else and putting it in for something. So that would be the substitution property. Substitution property. Then I have angle 1 is congruent to angle A and angle 3 is congruent to angle C. That goes with my alternate interior angles. That's the alternate interior angles theorem. Remember, angle A is here. So angle A goes with angle 1. Sorry, guys, I'm yawning because it's literally 1:20 in the morning and I'm recording this for you because I care about you guys. And I've been insanely busy up until this point. But I want you to know I do care about you. Moving on. Congruent angles have equal measure. So essentially what we're saying is that now the measure of angle 1 is the same as the measure of angle A, and the measure of angle 3 is the measure of angle C. But also I can say that measure of angle 1 is equal to the measure of angle A. Measure of angle 3 is equal to the measure of angle C. So now I have measure of angle A plus the measure of angle 2 plus the measure of angle C is equal to 180 degrees, and that's by the substitution property. So what I've done is I essentially proved the theorem 3-11. So again, proofs don't go away, ever. They come back and haunt you. However, we can use the triangle sum theorem to find the values of x and y in this diagram. So essentially what we have is x is here, y is here. You're like, what's z? You'll see soon. So x is here. I have a smaller triangle here, triangle ABD. All of those add up to be 180 degrees. So 43 degrees plus 59 degrees plus x is equal to 180. So knowing that, I can combine those two together. 43 and 59 should be 102. I'm doing this in my head. Plus x equals 180. If I subtract 102 from both sides, 102, you should get x equaling 78. I don't need to put degrees because it's already there. So that's how I get x. And then there's multiple ways to get y. I think the easiest is to take 78 from 180 because these are supplementary. Some of you will be like, what can I do, like something with 49 and 43? Well, not really. I mean, eventually you'll want to find, like if you're trying to find the whole triangle, but since we're just trying to find y, we're going to take 180 minus 78 because that's what x is. And you get 102. That's kind of weird because 102 degrees is the exact same measurement as this one here and that one here. So that's an odd thing. We'll see what's going on with that here in a while. So we have equals y. So now we have x and y. What are the values of x and y in the diagram? X equals 78, 102 equals y. So if you would, please go ahead and do the got it. The got it is to find the value of z. It's a little bit tricky, but I think you can figure it out. Sub, if you would go ahead and pause the video so my students could do this particular problem, that'd be fantastic. When you get done, make sure you check with your table, make sure you all agree. I'm going to assume my yawning was enough time for you guys to get the value of z. So with the value of z, you actually know a lot of the degrees of the big triangle. We actually don't need x or y. You can do it without it. We can take the big triangle, so 59 plus 43 plus 49 plus z, and that should equal 180. So if I combine 59, 43, and 49 together with my handy dandy calculator, tick, 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 tick. So I have 180. So I have 151 plus z equals 180. Subtract 151 from both sides, and you should get z equals 29. Hopefully we agree. Next we have exterior and remote interior angles. An exterior angle of a polygon is an angle formed by a side and the extension of an adjacent side. For each exterior angle, then there's two non-adjacent interior angles, and we call those its remote interior angles. So for example, angle 1 is an exterior angle, and angle 2 and 3 are its remote interior angles. So angle 1 is exterior, angle 2 and 3 are the remote interior. Sorry, same here with these guys, and 1, 2, and 3 with that. Oh, big deal. What does that do? Well, it actually goes with this theorem. So if you would go ahead and pause the video now so you can put this theorem in your postulate theorem notebook. That thing that we saw earlier wasn't just a coincidence. It's actually a theorem. The measure of angle 1 is equal to the measure of angle 2 plus the measure of angle 3. Go ahead and pause the video now, please. Okay, so moving on. Now we can use that. We use the triangle exterior angle theorem to find angle measures. So now I can find the measure of angle 1 simply by adding 80 degrees and 18 degrees. So if I do that, angle 1, measure of angle 1 is equal to 80 plus 18. So the measure of angle 1 is equal to 98 degrees. I do need degrees because it's not on the diagram. Bam, done. The measure of angle 2. This one's a little bit tricky because I add, So I add the measure of angle 2 plus the measure of angle 59 degrees, which is 59 degrees. Set that equal to 124 degrees. Subtract 59 from both sides. Those cancel out, and you get the measure of angle 2 is equal to, let's see, borrow. So that's 0, 12. Borrow again, it's 11, that's that. Should get 5, 65, that seems off. 11, no, I think that's it. 12, no, 75. 55, 71, 5. I think it's 65. Now I'm like double checking. Like, man, I am having a night. Don't try to do math at 1:30 in the morning. It just doesn't work. Minus 59. 65. No, I was right. Alright. Feel better about myself now. Degrees. Bam. Done. Make sure your degrees look better than mine. I'm using my finger on a touchscreen. Hopefully yours does look better. If you would, go ahead and do this got it. This takes a little bit to think about. So you're constructing, so grab rulers. You're constructing two angles of a triangle, and then they need to measure 53 degrees. And then it says, what is the measure of an exterior angle at each vertex of the triangle? So let's go ahead and make this together. I think that's going to be the hardest part. And then as soon as you make it, then you'll be like, oh, okay, I see what you're talking about. So two angles of a triangle measure 53 degrees. So two angles of a triangle measure 53 degrees. There's 53, there's 53. And it says, what is the measure of an exterior angle at each vertex of the triangle? So I want to know what the measure of that angle is, what that angle is, and what that angle is. So I'm just going to call them X, Y, and Z. So now that we have all that figured out and you have it constructed, go ahead and pause the video, and then go ahead and figure out what X, Y, and Z are. Thank you so much. Alright, hopefully the first thing you saw is you actually need to find out this other measurement here. I'll call it A. We need to figure out A as well. We know that the triangle has 180 degrees, so if we add 53 and 53 together, we get 106. 180 minus 106 gives us 74. So that gives us that missing value, 74 degrees. Now we can use that to solve all the other ones. So Z is going to be 106 degrees. I'm just adding the closest. X and Y will be the same because they use the opposite, which is 53 degrees. 53 plus 74 is 127. So you should have got 127 degrees for X and Y, and 106 degrees for Z. There we go. Alright, so there's your homework, folks. If you would, go ahead and finish it. Hopefully, if you have any questions, you can talk to your table. This shouldn't have taken too long, including writing with you guys in class. We should be a little bit over halfway. If you guys are back from lunch, make sure you use your time wisely. Please know that I am super excited for your quiz tomorrow. Don't forget you have a quiz tomorrow. Study. If you need help with anything, please message me on Remind. I'll do my best to get back to you. I hope you guys have a wonderful evening. Good night. Bye.